Okay, so my name is Richard Douglas. I'm here to talk to you about baselining today. So you might think this is a bit of a strange title. You may recognize this as a film. I've had a bit of a theme this year where I've tried to name all of my talks after either films or song titles. And the reason for that is it makes it a bit more interesting for me. I pick a film title and then try and choose a topic within inside SQL Server, so it makes it quite interesting. So if you think about The Day After Tomorrow, that was a disaster movie, and so what we need to be doing is we need to know what the norm was before this disaster so we can take heart from this and be able to move on. Okay, so this is why this topic is all about baselining. So who's this guy? As I've mentioned, my name is Richard Douglas. I'm the editor-in-chief of something called ToadWorld. ToadWorld is a Dell community site for SQL Server and various other database platforms. So I work for Dell Software, not Dell Hardware. Dell Software was, well, basically formed last year when Quest Software was acquired. So if any of you have heard of Quest and wondered where we've gone, we're now Dell Software. I've got a couple of SQL Server certifications, but more importantly for you guys is I'm very committed to the SQL Server community. I run a past chapter in Maidenhead in the UK. I also blog about SQL Server, pretty infrequently it has to be said, at sql.richarddouglas.co.uk, and you can find me on Twitter under the handle @SQLRich. If you do want to contact me, my email address for work is there, richard.douglas@software.dell.com. So that's possibly the longest email address in SQL, and a bit of a long one, that one. Okay, so what are we going to be covering today? So I asked a former mentor, what kind of things do you blog about? How do you choose topics? And I've used the same advice here in setting my agenda. So his advice was, choose something you would have wanted to know a couple of years ago that would have really sped up your career advancement. So when I think about baselining, what do I want to get out of that? And so these are the core subjects that I wanted to cover. This is what I think I would have wanted to know a couple of years ago. So I would have asked the following questions. What is a baselining? What is benchmarking? Where do I start in terms of having this as a project? What kinds of things do I need to capture in my baselining and benchmarking project? What tools do I need to be able to capture this kind of stuff? And I'm going to be covering 3 tools today, even though I do work for a vendor. And then we're going to summarize it all at the end. Hopefully, if my VMs are working, there's going to be a bit of a demo as well. Right, okay, so let's start. What is a baseline? So the most succinct way I could put this was it's a measurement or calculation used as a basis for comparison. This means that really it's kind of like a line in the sand. This is a point in time that we're going to be doing this. Apart from that isn't true. It's not really a point in time. I've started. I hope that's okay. Are we recording? Yeah, okay, great. So there was lots of rambling for me to start with. Hopefully that'll be cut out before it goes online. Right, so really, it isn't a point in time. Really, you need to be looking at the typical state of your system. So we talked about the day after tomorrow. That's the wrong time to start baselining. You don't start baselining when you have a disaster or after a disaster. You want to be doing it before. So the typical state of your system. Your baseline shouldn't be an atypical state, i.e. not the norm. So the next point is it should be an average over a time period. This is going to give us a much better indication of what's happening. So we need to be capturing mins, maxes, and various averages of all of our counters to make sure that we're getting meaningful information. Because if we just do a snapshot, a Monday morning might be completely different to a Friday afternoon, for example. So if I was to take a week-long average, I should get a much better indication of how my systems are performing. Another thing I should be saying is that we need to be doing multiple types of baselines, not just a single baseline, but I'll go into more depth on that later on. So that's what is a baseline, but why do we need to baseline? So as I kind of mentioned the phrase line in the sand, so we need a starting point to be able to do this kind of thing, okay? So we need a point so we can do further baselines or benchmarks in the future so we can create our delta points and then work out what's going on. This means that we have great ability to have trending information and usage patterns so we can work out what kinds of things are going to happen over time, which means we can be a lot more proactive in what's going to happen. Because ideally, as database professionals, we want to be proactive rather than reactive. That's why we get paid lots more money than somebody else, okay? Or hopefully get paid lots more money. Okay, so that's baselining. Any questions on that before I move on to benchlining? No, cool. Right, so what is benchmarking? Benchmarking is pretty much exactly the same, but the message I've come up with is a level by which something can be measured or judged. Okay, this means it's just exactly the same thing as a baseline, but we're going to use this as our delta point so we can work out the differences between point A and point B. Okay, this means that we're going to have information that we can make informed decisions upon. So data is meaningless, you need to have information from that data. So we're in the information services sector rather than information technology. So lots of people think that benchmarking is only for DBAs. That's not true. So it's also for developers. And can I have a quick show of hands? Normally I like to do a little bit of research on my audience. How many of you guys are DBAs by trade? Quite a few people. How many developers? Wow, that's nice. I like that. Okay. How many BI analysts? 1 or 2. Okay, you should be that side. I think John's doing a talk next door at exactly the same time. But hopefully you'll get something out of this. Okay, so performance tuning lifecycle. The first part of this lifecycle is that you need to define a goal. There is no way that you can performance tune something if you do not have an end goal in sight, because otherwise you'll never finish. You'll just try and make it faster and faster and faster. And at some point in time, you're going to lose your investment in time, okay? You're not going to have a good return on your time input because you could be spending an extra 2 days just to shave off half a millisecond or something stupid like that. Okay, so you need to define what your SLAs are going to be. So your SLA is a service level agreement. Some people use the term KPI, which is key performance indicator. So we define our goals. Then the next step is that we're going to be creating our baseline, okay? So I'm going to be telling you the kind of counters we're going to be using later on, but for now we're just going to be creating our baseline as our next step. After this, we need to be looking at our information and having a look to see if we can see any bottlenecks. I have mentioned before that we should be able to take deltas, but knowing some kind of best practices, we'll be able to see if there are some atypical counter values that we could look at straight away in order to go through and performance tune. Now, what I would say is that this says identify bottleneck. It's singular, it's not plural. I want to change one thing at a time. That is very, very important. If I made several changes at the same time, say I made 10 changes, and I got an overall performance improvement, what happens if 8 of those were actually negative and 2 of them are really good? Yeah, I'd be slowing myself down. Whereas if I made one change at a time, yes, it does take longer, but then I can make sure that each change I make is actually making an improvement. Okay, it's very, very important. The next thing we want to be doing is we want to be developing and testing our solutions. It's very important that you test stuff and not just deploy it live into production. Okay, so you're going to have like a mini test, mini baselining here, but we're talking about production environments here. Okay, so you're going to want to develop and test on other boxes before they're deployed into our live solution areas. Then, of course, we're going to want to deploy our change and push this into our live production critical environments. Can't stress enough, testing, you must test. Okay, and then the whole cycle starts again. So then we create another baseline, we see if our changes have actually improved performance, because it's one thing to test in a sandbox environment where you've got one user, but if you've got 100 users all doing the same kind of code, you might end up with concurrency and scalability problems. At that point, it might be that you need to go back. Instead of deploying, you actually go back and roll back and start all over again, okay? And then we identify the next bottleneck, and then the next bottleneck, and so it's a life cycle. So I think that any presentation isn't a true presentation unless you have an obligatory analogy. So I've got one lined up for you. I am going to make the best cup of coffee in the world. Coffee is very important to me. I need caffeine in order to survive through the day. I've got children, I've got a dog, I've got a young puppy that wakes up at silly o'clock in the morning, and so I do need caffeine to get me through the day. So my goal is to make the best cup of coffee in the world, and eventually I'm going to end up owning a chain of coffee shops called Doug Bucks or something like that, okay? So that's my goal. So the first thing is, my baseline is going to be, I'm going to be making a cup of coffee. Pretty straightforward. I make my cup of coffee, and then I need to analyze my cup of coffee to see how it tastes to me. Now that might seem subjective to some people, it's a personal preference, but let's think about our SLAs, our service level agreements. This is arbitrary as well. Some person inside your business has said, this query must respond in n seconds or n milliseconds. That may be as arbitrary as my taste buds in a cup of coffee, okay? So this is just a figure that somebody has come up with. Admittedly, you're paid to meet this figure, but it's still potentially an arbitrary figure, okay? So once I've gone through, I've analyzed it, I think what I might want to improve on. So at that point, I'm going to decide on a change. I might decide to go for mixed beans, single beans, whatever it might be, heated milk, different temperatures, all that kind of stuff. And then I'm going to analyze, I'm going to drink the coffee and make another cup. And this I'm going to go through round and round and round over and over again, either until I've made the best cup of coffee in the world, or I'm so hyped up on caffeine that it's really unsafe for me to operate machinery anymore. So there we are, that's the life cycle. Hopefully that makes it a little bit clearer and highlights my need for caffeine. So when should we be capturing baseline information? All good. It depends. You weren't really going to expect anything else, were you? I'd be very disappointed if you did. So really I should be backing this up with what it depends on. So I mentioned that you really should have different types of baselines, and this is based on the different kind of workloads that you're going to be having. So one of the different kind of different kind of workloads you should be having are maintenance windows. There is no real point in me having my maintenance window included in my major baseline. And the reason for this is I'm going to be backing up my databases. That's extra I/O in a different I/O pattern. I'm going to be doing index rebuilds. Again, that's not typical behavior for my user systems. And all things like that. So if I'm looking at my disk usage, my disk throughput and things, that's really going to skew my daily data if I'm including this. So I'm going to want to remove this data from my overall baselines. Now I can do this multiple ways. I can either subtract and remove that data out from the database or whatever platform I'm storing this in, or I can create different baselines. Okay, so there's different ways I can be doing this. Likewise, the next points are month, quarter and year end. So this is all to do with your business reporting. Now I know I've worked for some small companies, and I'm sure some of you guys have as well, that I've worked on systems where you have a single OLTP transactional database, and this database is also your reporting database for your end users and management. It's not nice. And therefore, if I'm baselining on this kind of environment, my month-end kind of workload is going to be very different to anything on the previous 3 weeks, okay? So again, it's going to be atypical data, so I'm going to want different baseline from that. Okay, so that's not going to be my normal baseline, and I should be taking that away, squirreling it away and storing it, because I'm going to want to be looking at that data year on year moving forward. And the same thing goes for seasonal peaks. I used to work for a lingerie company. Obviously, I was a swimwear model. No, I wasn't a swimwear model. I was the DBA there. As you may tell. Was an interesting job. So they had seasonal peaks, and because they did swimwear as well, our seasonal peak was the month of August, where we had 1 or 2 days of sunshine in the UK. And so those days of sunshine were really, really hectic, and everyone wanted to buy swimwear just in case. Or of course they all went abroad and got sun, which tends to happen. Sorry, I'm going to cough, so I'll mute this for a second. I don't want to blow your eardrums out. Okay, so the problem with seasonal peaks are that this is, again, it is atypical, but if I have a baseline just of my seasonal peaks, this means that I can be really, really proactive. And the reason for this is I can have my typical workload with my usual baseline, and then I can have my seasonal peaks baseline. Now, if I'm taking multiple baselines moving along on a monthly basis, for example, I can take the delta between point A and point B on a year-on-year basis, and then I can say, what's the delta between now and my seasonal peak? So then I can work out what my seasonal peak is going to be this coming year. And so I can go to my IT director and my financial directors, and I can say, this is where we are. Last year we had this much headroom in terms of our hardware resources, or we had to do this much work with our development team to make sure things were scalable. We're going to need to put aside budget to be able to do this again. Now, this might be going to one of the vendors outside and buying a nice new SSD drive for our I/O subsystem, or it might be getting lots of overtime for our developers to make sure things are running smoothly. But this does mean that your databases are going to be running nice and smoothly and efficiently when it comes to your seasonal peak, and that makes you a good data guardian, okay? It also means when it comes to pay rises, you're going to be first in line, which is quite nice. Other things, you're going to want to take new baselines after every service pack and every fix that you make at both the operating system level and at the SQL Server level. The reason for this is there are going to be changes in the optimizer and things like that when it comes to SQL Server. There are features and bugs that are going to be fixed. They are going to have different performance impacts. So every time I do a server upgrade of any kind, I want to make sure that I have a new baseline in place, and this is going to be my new starting points. Of course, I need to check that against my old baseline, and if I have a decrease in performance, it might be that I need to speak to the business and say, you know, here's where we are, there's this security fix, it's causing me a performance problem, what would you like me to do? Okay, not a great scenario, but you put that back to the business and say, what's the risk here? Another thing, how many of you guys have DR sites or using any kind of HA? Couple of people. Okay, how many people baseline their production systems now? Oh, I'm glad you came today. There's not many hands there. Okay, so how many of those people who baseline their production system also baseline their HA systems, their disaster recovery sites? I'm looking for a hand here. Somebody, please. Okay, right, so what was to happen if you were to fail over? You have no idea what kind of level of performance you're going to see. That's going to be a problem. What happens if this failover time is a seasonal peak? Maybe you've had some disks blow out because, I don't know, you've had too many people surfing at the same time or something stupid like that. So I need to be taking things like replay traces and taking those onto my other boxes and checking to see how they perform under the same kind of workload. And then I can take deltas between the two, and again I can then go to my finance director, my IT director, and say, hey, it's really great that we have this other site that we can use, but are you aware of the performance impact that's going to happen once we actually fail over? Is the business going to be happy that A, we're running, or B, we're crawling? You know, this is a very important thing. It might be the business are happy that you're just up and running, but your users might not be, and how much is that going to cost the business if you lose their customer service, okay? So it's very important that you do look at trying to do failover tests and replaying things in disaster recovery sites as well. So the next point we have is after any new project and deployment, and that kind of comes back to the whole performance tuning life cycle, so we've already touched on that one. Any questions at this point at all? No? Okay, that's good. So now we move on to what kinds of things should I capture. So there are 4 things. The first one is system configuration. We need to know what's happening at our server levels. We're going to be capturing Windows operating system counters. We're going to be covering system SQL Server counters, and also we want to be looking at wait statistics as well. Okay. So system configuration. This screen looks surprisingly like some kind of DR document to me, and in fact it is. It is exactly what you should be having as part of your DR strategy. I need to know what is touching SQL Server, maybe appropriately or inappropriately, in terms of other servers, okay? I need to know what is happening, because if somebody comes to me and says there's a performance problem, I might be looking at just SQL Server and everyone else is just blaming me. But if I know what's happening around side SQL Server, the periphery technologies, I can say, actually, SQL Server's okay, and I'm also monitoring all this other stuff and capturing metrics from this. It's not me. You want to be speaking to the SAN admin, or you want to be speaking to the VMware guys, or whoever, whatever hypervisor you're using. And things like that, or file servers, or SharePoint servers, or whatever it might be touching your SQL Server databases. So I want to be capturing Windows and SQL Server version information. Again, we mentioned about upgrading and things like that. How am I going to know what to regress to if I didn't have that information to start with? So it's very important I have version information. Likewise, in a DR scenario, I'm going to want to be able to rebuild this on my DR site if I've got a cold server rather than a warm server. Okay. As a little side topic, I was once asked the difference between a cold backup and a warm backup. I was in a rather flippant mood, so I said to the guy, a warm backup is when the aircon fails in your DR center. Okay, so yeah, SQL Server information. So we also want to be looking at our driver information, because our drivers might be causing us problems, and there are going to be updates we want to perform on drivers for our SANs and things like that, for example. Again, so it's great to have that kind of information when we're moving to DR sites or doing any kind of upgrade. I/O subsystem information. Now this can be a bit tricky, but ideally as a DBA I want to know exactly what's going on. I want to know where all my systems are. Obviously if you're in a massive multinational corporate environment and you've got a couple of hundred instances, I spoke to one guy recently who had 600, which is a bit manic. You're not going to know what each I/O subsystem is, but if you're working in quite a small shop, then you really should make it your business to know what's going on in terms of I/O. System catalog information, it's quite easy to get this kind of information, so look at sys.configurations, see what your server settings are. You might find out as part of this that you've got atypical settings across your environment, so it might be quite nice to standardize those. Have a look at sys.databases and sys.master files to make sure that you've got nice best practices in place, like your log files and data files separated, all that kind of stuff. Not such an issue if you were using SSD, but if you were using traditional media, then you'll probably want to split that out still. I did have on my previous slide operating system counters and SQL Server counters split out. What I am going to do is I'm going to consolidate these and I'm going to put these into different areas. So the three different types of areas we want to monitor in terms of SQL Server are something like that Christian Bolton likes to call the holy trinity of resources. So this is memory, I/O, and CPU. Okay, very, very important that you do that. So I see some people taking pictures. I'm going to add up some more information on this in a second, so you might want to take a picture again in a bit. Also, it's going to be available online later and to download as a PDF or something as well. So memory available megabytes. This is the amount of memory available to your operating system after SQL Server's been using it. So this is what is free available to the to your Windows operating system. Now you're really going to want a fair bit for this, because SQL Server has a max memory setting. Okay, hopefully you all know about this, but the max memory setting isn't for the whole of SQL Server. It's for the buffer cache and all the caches that kind of sit inside of the buffer pool. Okay. So things like your plan cache and stuff like that. This means there are other things that happen outside of this. So if you perform a backup, this happens outside of that memory space. Depending on the version of SQL Server you're using, CLR happens outside of this and other things as well. Okay, so if you don't set your max memory, you could find that you're going to get some kind of memory pressure later on, and what's going to happen is your operating system is going to try and reclaim this, which means you're going to end up paging to disk, which isn't great. But it does provide a nice segue to me on paging. So really I want to see 0 for my paging. If I'm paging to disk, I have got some severe memory pressure and I'm stuffed basically. I need to get some more memory, or I need to find the root cause of why I'm using so much memory. Okay. So this isn't a root cause session, this is the kind of thing that you should be capturing session. So target server memory is what SQL Server should be using based on your max memory settings. Total server memory is the amount that SQL Server is actually using. So ideally you want these to be the same. If you have target server memory and you see this going down, you are seeing memory pressure problems, and so that is going to be a big red light bulb going off, probably the bat phone and various other things as well. Memory grants pending. If I see a value for this other than 0, it means again I'm receiving memory pressure because I'm waiting on memory to become available so I can perform this query. So that's going to be a problem for me as well. Or again, it could be that I've got a really big query and maybe I need to tune that to return less information and therefore use less memory. Now the reason the buffer cache hit ratio is scribbled out is that this used to be a very good indication, but it's not such a great one anymore. So we tend to use page life expectancy. Now, some people are going to say 300, what's this guy doing? What does he know? And yeah, you'd probably be right. But 300 was a value given some time ago. So I'm going to state now, every value in red you see here is an absolute lie, okay? These are values that were given at a point in time as best practices, but if you look at Moore's law, technology moves on, and so really these standards or threshold levels are going to need to move on as well. So for example, when this 300 level was set, so this is the number of seconds that data is going to stay in my buffer pool. This was 32-bit machines, 3 gig of RAM. I've been on customer sites tuning servers which have got half a terabyte of RAM. 300 seconds with half a terabyte of RAM, ooh, that's pretty scary. I really wouldn't want to be there. So we need to kind of be extrapolating this out based on the kind of hardware that we do have in our environments. Now, a counter you might not have seen before is this next one, which is SQL Server Buffer Manager Extension Page Unreferenced Time. Does anybody have any idea what this might be? No? Okay, right. So this is new in SQL Server 2014. I took this from a CTP1, so it may have changed slightly and probably will change by the time it comes out in RTM. But this is the exact same as page life expectancy, but this is for our extended buffer cache, okay? So this is a new piece of functionality in SQL Server 2014. And the idea is you have a central buffer cache, which is in memory, and then you're going to have an extended buffer cache, which ideally is going to be on some kind of solid state disk device, okay? And the idea is that then this is some kind of secondary cache, and it's going to be quicker and cheaper for SQL Server to go to this than traditional spinning media. And so it's an architectural change that the SQL Server team have put in place. And so this is the new counter which tells you the equivalent of page life expectancy. Now, because it's not in RTM yet, there isn't going to be a best practice for this. So I've kind of taken it on myself to say, oh, well, let's have an arbitrary figure for this. So what I'm going to suggest is that you have your page life expectancy, and then you times this by n, okay? So n is going to be the number or the ratio between your size of your buffer pool and your extended buffer pool. Now, if you look in books online for SQL Server 2014, it recommends a ratio of either 1 to 16 or 1 to 32, which is why I've got 16 or 32 up there. Now, this is just my advice, having not played with it in a production environment yet, but this is something that might take on, okay? The next two things are database pages and procedure cache pages. And so these are the kinds of pages within my buffer cache, okay? So database pages are my data pages, so the number of data pages inside my cache, and procedure cache pages are the number of pages that are used inside my plan cache, okay? So if I see my plan cache pages go up, it might be that I've got some kind of plan cache bloating going on, which means that I'm actually pushing out data pages, okay? Again, that's memory pressure for me. So I want to be looking at my plan cache and say, hey, what's going on here? So I can't give you good figures for these because it's going to depend on your environment and the amount of memory you've got, but just to let you know. Now, I've kind of said that everything I've said is a lie, and this is one of the reasons. Obviously, a lot of you are going to be using hypervisors, and this is going to hide the true value of things like memory. So I'm not a VMware expert, I haven't got the VMware certifications, so I'm not going to go through all of this, but what I am going to say is that your VMware admins can over-allocate memory, and so what will happen is it will actually page to disk to provide you the extra memory that you think you have. So what I would recommend is that when this presentation is available to download, that you do go and click on this link and have a good read of this document, okay? So let's move on to CPU. Okay, so CPU is obviously our central processing unit. So processor time, what would be a good value here? So typically the standard expected value is 80%. Hopefully I've clicked on it. Yep, 80%. So less than 80% is considered good for this kind of thing. Okay. Now, processor time is everything that's happening on that Windows box. That may not be indicative of what SQL Server is actually using. So if we look at the next counter here, this is processor time, and we can see what each process is using. So really we need to see what SQL Server is using. So if we look at the SQL Server process, then we can see what that's using, okay? So I've been on customer sites doing performance tuning and server health checks and things, and I've seen servers running at 90% CPU, and when you look at what's going on underneath using some of our diagnostic tools, you can see that it's actually SQL servers using something like 5%, and it's something like antivirus that's running in the background absolutely hammering the machine, which isn't great. So it's always a good idea to see what SQL Server is using alongside this, okay? If we don't have time for the demos, what I will say is when you are looking at your processor time, take all instances, not just the total, because I've been in scenarios in the past where I've seen some things running in single thread mode instead of using parallelism, and I've had one CPU thread pegged at 100% and all the rest at 0. If I'd have just looked at total, I would have seen something like 25% usage and gone, hey, it's great, and that's not true. Okay. System processor queue length. Now, they do recommend that it should be less than 12 and ideally less than 4. This is going to depend on the kind of processor you've got, okay? If it's hyper-threaded or not, all that kind of thing. The amount of cache you've got, all that kind of thing. So again, it's a line in the sand that you can look at. Context switches, so how many times does it switch per second between different threads? The figure I was given was less than 3,000, ideally less than 1,500. They're still really high numbers, it does scare me quite a lot, but apparently that's quite good. Oops. Let's go back. SQL compilations per second and recompiles per second. I can't give you a good indication here, but what I would say is if you're having recompiles, then obviously SQL Server's doing a lot more work than potentially it needs to. So you need to see what's causing these recompiles. So you can run things like profiler traces to see what the recompile is actually doing. You can get the reasons for the recompile. Whenever you're using profiler traces, please do server-side traces rather than client-side traces, because it will kill your servers. So as I said, I can't give you good indications here, but you do want to be looking at the ratio and the ratio over time here. So the next thing we want to be looking at is I/O. Again, I'm going to lie. Well, I'm not going to lie, I'm going to give you a question mark. So the figure used to be anything greater than 1 is a problem. There's a queue. I have an I/O bottleneck. That's not strictly true anymore. That was in a day when we all had local disks and everything went through. There was no smarts in front of what was going on. We didn't have lots of SANs and things which worked out what was going to happen. These days, we have vendors that say, give me as much information as possible, and what I'll do is I'll look at your queue and I'll reorder it to make the best use of what's going on. So I know this seek is next to that seek, I'll do a scan for those couple of sectors. And so it's not first in, first out anymore, it reorders it. And so those vendors will like to have a larger queue depth so it can do smart things to give you better performance. So for this, I do recommend that you do look at your disk vendors and see what they recommend, and then make sure that your servers do adhere to that kind of information. So disk seconds per read is my latency. What's my latency for reading from disk? If you look at the SQL Cat Team white paper, this said for an OLTP, so a transactional environment, 20 milliseconds. Now again, this is probably a lie. This is based on disks having like a 4 millisecond seek time. Now, if I'm using an SSD, I'd want this to be sub-millisecond. I'm paying a lot of money for a lot of performance. If I'm seeing 20 milliseconds from this, that's a big problem for me, okay? So you are going to want to tailor it for your environments. For some environments, 20 milliseconds might be really, really harsh. See what your users shout at, okay? It's a horrible way of doing it, but if you have no budget, trying to get to 20 milliseconds might not be possible for you and your disk I/O subsystem, but just keep an eye on what's going on. In terms of writing needs to be faster. Why does writing need to be faster? This isn't a rhetorical question. Anyone? Why does writing... Sorry? Yeah, it needs to be written to the log to make sure that things are durable. This is going to hold up your transactions if you don't have a fast I/O subsystem. This is why your latency needs to be less for your log files, okay? So do make sure that your log files are on faster disks or as fast as you can make them, okay? Bearing in mind that this typically tends to be sequential throughput, okay? Not always. There are things that break that, especially if you have multiple log files on the same LUNs, for example. So bytes read and bytes write are going to be my throughput. So the seconds per read and seconds per write is my latency, and the next two are my throughput. Again, I can't give you good figures for these. This is where you need to go back to your vendors and say, what kind of throughput can I expect? And before you've got into this stage, you really should be saying, what kind of throughput can I expect from my system before I get into production? This is where I should be using tools like SQL IO Sim, Iometer, things like that, to be able to stress test my disks to see what performance I can get out of them. Okay, so I can't give you good indications of that, but obviously if you see better performance over time, that's a great thing. And if it's going down, you need to ask questions why. So do keep an eye on that as well. So I keep going back to the point that I'm lying, and I'm very aware of the fact you've paid to come here to hear me lie, which is a bit worrying. But we do have problems when it comes to SANs, because we are in fact in a virtualized environment now. It's virtualized storage. We have no clear indication of what we're sharing with in a multinational corporate environment. So I could be sharing with the same LUNs with Exchange, SharePoint, all other kinds of things which have different I/O patterns with me. Ideally, I'm going to want to know how it's connected, so I can make best use of things like my fiber channels, make sure they're connected properly. I want to know how many spindles, are these spindles dedicated to me, so I can see and try and work out what my service level agreements should be. So I need to have a good relationship with my SAN administrator or administrators, possibly take them out for a drink. It's a very good investment in your career, okay? So these are the kind of things that you're going to want to know. And again, how many other servers share this? For SQL Server, you're going to want to get the most performance out. So do try and get dedicated boxes if you can. Dynamic storage. I've heard some horror stories about this. So this is kind of like the automated tier system where your data can move about. In theory, it sounds great. And for some scenarios, it is. Now, what can be the problems with dynamic storage? If I have an automated tier system that says, I have this information, if I'm not using it very often, it's going to move down the chain. What could be my problem? Anybody? Yep.
Something starts moving when you're using something else.
Yeah, so it's the fact that it's unpredictable. So if it's being moved, how am I going to know where it is? How can I enforce service level agreements if I don't know where this data is going to be coming from? So SQL Server has its buffer pool, and so this is where the most frequently kept data is. So if I'm already got my frequently kept data here, and in my extended buffer cache here, if I've got automated storage, it's likely to be quite low down in my stack of things. It's not likely to be in my fast top tier storage. Now, a lot of providers can turn this on and off, so it might not be the end of the world if you have got this. I'm not saying don't get it by any means. I'm saying you need to test this kind of stuff before it goes into production. So what is a good way of testing for consistency? I as a production DBA, I've done data center migrations and things like that, and I wasn't allowed to do SQL I/O tests. They said, no, for God's sake, don't do that. We've got other clients on the same SAN. If you do that, I won't be happy. So I just got a 400 gig database and did lots of backups and restores instead. They can't tell me off for doing DR testing. And using that, I could work out what my disk throughput was for both my reads and my writes. And that was a very good indication for me that I was on a slow SAN and they were actually lying to me. Okay, so it's a very good way of finding out if they're actually telling you the truth. You could be paying them for a service that you're not getting. So by doing this, you're doing tests. It's also very good for DR. Okay, so other things that we should be capturing. These are kind of ad hoc SQL Server counters. What time did I start? I've got 15 minutes. Okay, right. Forwarded records. If you do not have clustered tables, you have something called a heap. If you have a heap, there is a chance you could have something called forwarded records. I'm not going to go into the internals. Basically, this is a bad thing. It causes you performance problems. So ideally, you want this to be 0. If it's not 0, you're going to have problems. Do look up forwarded records on Google, or Google with Bing, as a Microsoft guy I know likes to say. And there's a Kimberly Tripp thing which will explain all about that kind of stuff. Page splits. Page splits are bad for performance. Really, you want this to be 0. Problem with this is it depends, okay? And the problem with this is that this counter will also incorporate things like new page allocations. A new page allocation, which is a good thing, because if I don't have new page allocations, it means I've run out of disk space. Oh, that didn't click. There we go. If I don't have new page allocations, then I've got a problem, but this counter does include new page allocations. So again, there is quite a good blog post, I think it's by Jonathan Cahias, who's worked out a way that you can do this using extended events. Okay. User connections, beware of pooling. I cannot get a definitive number of connections if my application is using pooling, because it will use the same connection over and over again. That's going to be a problem for me. Batch requests per second, so the number of transactions that's being pushed through, I want to keep an eye on this over time. This is going to be very interesting when we're talking about our seasonal peaks. Okay, page reads per second. So we talked about our buffer pool. And so buffer pool, this is the number of times we're reading from physical disk to get information per second for information in our buffer pool. Ideally, you want this to be less than 90. Now, this is really going to change. I'm not sure how our extended buffer cache is going to change this. It might be that that figure doesn't matter as much because it's going to incorporate that figure, which isn't going to be as expensive. So we do need to be thinking about how this is going to work. Likewise, the number of page writes we're going to be doing is quite important as well. Now, this figure is also going to incorporate checkpoint and lazy write operations as well. So you're going to want to take those counters as well and cross-correlate those figures. So what other information should we be capturing? So I think that really, as a DBA, you need to understand the workload of your servers, otherwise you're not going to truly know what's happening. It's going to be quite an abstract concept if you don't. So you really need to be looking at the information, so things like running traces, extended events, to have a look at the queries that are running. Another way you could do this potentially is by extracting the plan cache. Now, a problem with doing this is that the plan cache is quite transient. Things can get aged out of your cache. Certain queries never get in your cache, so that might not be the best way of doing it, but it's a way of trying to find out what's going on, and you can get information from the plan cache about how much CPU time and how much physical reads and writes and things like that it's done as well, so that might be useful to you. So do bear that in mind. Something I like to do is I like to take my Msdb backups and I like to restore them somewhere else, and I like to take the information about job history out of them. Then I can make trend analysis on how long my jobs are going to take moving forward. Again, this is great when it comes to month end and year end and seasonal peaks. I can predict how long my jobs are going to take ahead of time potentially. Okay, very important. It does make me a very valuable member of the team. Wait statistics. I'm not going to spend too long on wait statistics because we are probably going to run out of time, but there are a couple of dynamic management objects that you can query, and it's a good idea to take deltas so you can see what's going on there as well. So what free tools or native tools can I use to capture this kind of thing? Typically you're going to be using perfmon. That's the kind of generic name for it. It does change every so often. System monitor, performance monitor, whatever you like to call it. This is what you're going to capture your operating system counters and SQL Server counters with. Of course, everything else you're really going to be capturing with something like Management Studio, possibly with Visual Studio, SSDT, things like that. For your query information, you'll be using things like Profiler. Profiler was deprecated, well, marked for deprecation, I should say, in SQL Server 2012. That doesn't mean you can't use it, and also it's just for the database engine, not for analysis services, so that's going to be around for quite a while. Also use extended events because that's got a much lighter footprint. Okay. So how do we analyze this? So I've just been talking about the kinds of things that you want to capture, not how you're going to analyze. There isn't really enough time in an hour to go through absolutely everything. So Brent Ozar, when he was working for Quest Software, did a presentation at SQL Bits, which is recorded. If you do go to that bit.ly link, you can see how he uses things like Excel to work out what he's captured, and then goes on and, sorry, that is case sensitive, by the way, so you're going to want to click on that link. So how he goes through and sanitizes the data and makes better use of the data, turning it into information. And there's a great wiki article on Toad World as well, which kind of talks you through some of the things I've spoken about today. So hopefully we have still got time for a demo, so let me nip through here. Okay, so what I want to do quickly is I want to show you how you can do some quick correlation between Profiler and performance monitor. So what I'm going to do here is I'm going to break all the Buck Woody best practices, and I'm going to type in a demo. So I'm just going to create a generic trace. This is obviously a demo, so this isn't best practices. I'm going to run this as a client side thing. Obviously you want this to be server side, but I'm going to start this off. I'm going to run. I'm going to go into perfmon, and what I've got is I've got some data collectors already set up in a true Blue Peter style. Do you have Blue Peter in Europe at all? So Blue Peter was a kids TV series, and they said, and here's one we made earlier. Okay, so this is the same kind of thing. So I'm going to start this off, and now I'm going to talk to you about how you would use data collector to collect all your information from perfmon, so you can schedule this and capture it. Okay, so the first thing we're going to want to do is we're going to right click on our use defined, click on new and data collector set. Now you can use templates, and what you can actually do is you can save what you're doing now as a template and export those to other machines, which is a great way of doing it. But what I'm going to do now is I'm going to manually create one, which apparently is advanced, which is weird. Okay, so I'm not going to do performance counter alerts, I'm going to be looking at performance counters. Click on next, and all I do now is I add in the counters. Now obviously it's going to take me a long time to do all this, so I'm just going to add some random ones. I'm going to, as I mentioned before, I want to look at all instances of things, not just total. Very important when you're doing this for things like disk and CPU, otherwise you're not going to get a true indication of what's happening. Let's grab some SQL ones here. Let's grab some access methods. Oops. Buffer manager. It doesn't really matter what I'm grabbing, to be honest. So let's just say we want those. I did skip over that a little bit briefly. In the last step it said what's the sampling rate that you want to take, so the default is every 15 seconds. Now that obviously the more frequently you do this, the more overhead there is on your systems, so it might be that you want to make this quite a larger sampling rate, so you want it to be every minute or 2 minutes, something like that. Depends how granular you want your information to be. Okay, so this is where you're going to be saving your information. Do make sure you've got room for this, okay? Lots of people have very small primary drives. So we're going to save that, and we're going to close that. So I called that, oh dear, I didn't name that properly. So new data collector set 1, that was really bad. But if we have a look at our properties, this is where some of the interesting stuff comes in. So I can see where it was, I can see how it's being prefixed, I can use serial numbers, etc. I can set security on it, but what I want to be doing now is I want to be proactive, and I want to be scheduling this kind of stuff, okay? And this is where I can do this. I can go in and I can say, how do I want to schedule this? What days do I want it to run on? So by default, I can have it every weekday. And then I can go through and say, when do I want this to stop? So before I talked about having multiple different baselines, so I can set my maintenance window baseline to happen between, I don't know, midnight and 6 a.m. or whatever it might be, and I can have my other baseline happening between 6 a.m. and midnight, for example. So by default, it's going to give me a .blg file. There are ways that you can change this into CSV and things, and if you watch the Brent Ozar video, he walks through that. So what I'm going to do now is I've waffled for a bit, so I'm going to stop this now. And then I'm going to go through and I'm going to stop my profiler trace. So I now need to go through, I need to save my profiler trace, and let's call this Nordic Rally Live. Well, it's obviously not live on the recording, hopefully they can change that using some magic. Right, now, weirdly, and rather unintuitively, I now need to close this. You'll see that there's a ghosted out option here for import performance data. I can't import this performance data now. What I need to do is I need to close this trace, and then I need to open it again, which is great. That's not a waste of my time. Anyway, right, so now I can click on File and I can import my performance data. Maybe this is why it's being deprecated. Okay, so is that my latest stuff? 802, no, that doesn't seem right. Okay, let's go back to my webcast. There's my latest folder. Of course, I don't have permissions. Let's click on Next. Let's run that. And now, what I can do is I can capture far too much information. So I can say, I want to capture absolutely everything in case there's something I'm not aware of. And then when it comes to correlating, I can say, actually, I just want to choose these things. Because this is a live demo and it's being recorded, I'm going to select everything. Because I didn't capture too much, it's not going to be too much of a problem for me. But what you can see here is I now have my query workload, and I can see what's happening in terms of my operating system counters. And these are correlated together. So I have a peak here. If I click, this was what was running at that point in time, which is kind of cool. And I've got this for free until they get rid of it completely. Okay, so that's quite a good thing, and again it works the other way around. So if I start scrolling through here, you can see the line moving along, so I can see what's happening for each bottleneck. So if I've got an IO bottleneck, I'll have a look at my IO counters here and I'll see what queries are running. If I've got CPU bottlenecks, I'll do the same thing for CPU, for example. So it's quite a nice way of being able to correlating what queries are causing me certain types of bottlenecks. Okay. Now the problem with this is I might be a DBA of 100 instances. This is quite time consuming, and this is where other vendor solutions are going to want to come into play. So hopefully you found that useful. I do love this slide. This slide has been plagiarized quite significantly from something that Gartner did. I have given them the Gartner logo. So this is the mature information management process step ladder, or it's your career progression chart, as I like to call it. So as you start off as a junior DBA, you're probably going to be in a fairly smallish company, and you're going to be in level 0 or level 1 at a small company. Everything's going to be really hectic. You're not going to be proactive. Everything's going to be, we want it yesterday. Why is this fallen over? Why haven't you done this? What's going on? Everything's going to be ad hoc. Everything's going to be undocumented. Now, as we start with our baselining projects, we're actually going to be going through the process of documenting our systems. Check, we're no longer in level 0. That's a good thing. Things aren't going to be unpredictable. We're going to be setting SLAs, and we're going to be trying to find out what the problem is and trying to resolve that. So we're automatically moving out of level 0, at least in terms of mind shift, and moving to level 1. At this point, we're starting to become more reactive, okay? It's no longer a chaos environment. We're no longer monkeys typing on typewriters. We kind of know what we're doing, okay? So we're still fighting fires. There are still going to be problems, but at least we have a plan to deal with this kind of stuff. We know where we're going. And this is where we're going to want to combine our baselining with things like alerting. So if I have a threshold of 80% on my CPU, or I have my disk I/O latency going above 20 milliseconds, I can create alerts in whatever monitoring system I have to ping me an email, and I can be more proactive about that kind of thing. So moving on to level 2, being proactive, I can start to analyze my trends because I have a baselining and benchmarking system in place. I can see what's going to happen. I keep harping back to my seasonal peaks. I know what's going to happen. I can predict what's going to happen. I can speak to my financial directors and make sure that I have the right kind of infrastructure in place, or at least they're aware that there could be problems if there isn't enough budget to be able to sort that kind of things out. So at this point we've moved past level 2 and we're looking at level 3. So we're really trying to guarantee our SLAs by having baselining, okay? This is where we dive in to find out where our problems are so that we can make sure that we are guaranteeing our SLAs. So baselining and benchmarking kind of puts you in level 3.5 if you like, okay? So point 4 is kind of more of a business mindset where you're looking at IT being a strategic partner. Now, I don't agree with the term IT. So IT is information technology. We're really information services. We're providing a service to the rest of our business or our external customers. We're not technology people. We're service people now. So there's a mind shift to be done there. So that's pretty much it for me. We've covered 2 minutes to spare. We've covered what a baseline is, the benchmarking process. We've also looked at how you're going to be planning your baseline, the kind of ways you're going to be implementing it, choosing your measures, and the native tools that you can use for this. So I'm just going to ask if there's any questions at all. You've been really quiet so far, which is good and bad. I don't know if you're listening or not. Okay. So there was some kind of noise, so that's a positive sign. Okay, so thank you very much for attending. I hope you found it useful. There are feedback forms apparently, or there's an app actually, I believe, so you can provide feedback. Hopefully you have enjoyed the session. If you want to get hold of me, I will be available outside. I am flying off to Amsterdam later, so I won't be around all day. But you can get hold of me on @SQLRich on Twitter. Likewise, there's my blog. There's a contact me page on there, or you can email me at richard.douglas@software.dell.com. Okay, so I'd like to thank you very much for your time. Thank you.